Remember that in our previous video, we created 4 new variables: high sodium, high fat, high carbs, and high protein. Now in this video, we will try to understand our data and the relationships between our variables better using the table and t-apply functions. To figure out how many foods have higher sodium level than average, we want to look at the high sodium variable and count the foods that have values 1. We can do this using the table function and give it as an input the high sodium vector. Now pressing enter, we obtain the following information. Most of the foods in our data set, and precisely 4,800 of them, have lower sodium than average, and we have 2,090 foods that have higher sodium content than average. Now let's see how many foods have both high sodium and high fat. Well, to do this, we can also use the table function, but instead of giving it 1 input, now we can give it 2 inputs. So let's go back using the up arrow and now have the first input being the high sodium vector and the second input being the high fat vector. And we obtain the following table. The rows belong to the first input, which is high sodium, and the columns correspond to the second input, which is high fat. So from the table, we see that we have 3,529 foods with low sodium and low fat, 1,355 foods with low sodium and high fat, 1,378 foods with high sodium but low fat, and finally 712 foods with both high sodium and high fat. Now what if we want to compute the average amount of iron sorted by high and low protein? Well, to do this, we can use the t-apply function. Let us have a little refresher on how the t-apply function works. The t-apply function takes 3 arguments and groups the first argument according to the second argument and then applies argument 3. For instance, we wanted to compute the average amount of iron sorted by high and low protein. In this case, the first argument is whatever we are trying to analyze, which is the iron vector, and we are sorting it according to the vector high protein, which is our second argument. And finally, we apply the mean function in R on the sorted iron values, and we should not forget to remove the non-available entries. So what does t-apply do exactly? Suppose that we have the following data frame with the foods 1 through 6, along with information about their iron levels and their values of high proteins that we just added earlier. The first step is grouping the iron data according to the values of high protein. So first group all the foods that have high protein equal 1, and that would be food number 2 with 12.8 milligrams of iron, food number 3 with 1.44 milligrams of iron, and food number 6 with 2.29 milligrams of iron. Then we group the remaining foods that have protein levels below average, and this corresponds to food 1, food 4, and food 5. Then we compute the mean of iron level for each group. In this case, the mean of the group with high protein levels is 5.51, and the mean of the group with low protein levels is 1.72. And this is the result of the t-apply function. Now let's go back to R and have a hands-on practice on how to use the t-apply function. So let's compute the average amount of iron sorted by protein levels. So we're going to type t-apply, and then the first argument is the iron vector, which we're trying to analyze. And we are sorting it according to the high protein vector, so this is our second argument. And then the mean statistic is used because we're trying to calculate the average level of iron. And do not forget to remove the non-available entries by typing na.rm equals true. And here's the result. Foods with low protein content have on average 2.55 milligrams of iron, and foods with high protein content have on average 3.2 milligrams of iron. Now how about the maximum level of vitamin C in foods with high and low carbs? Again, we're going to use the t-apply function, so use the up arrow to go back to the previous command. But now we're trying to analyze the vitamin C vector, so this is our first argument. And we are sorting it according to high and low carbs, so the second argument is the vector high carbs. And instead of the mean, we're applying here the max statistic, And we obtain the following. The maximum vitamin C level, which is 2,400 milligrams, is actually present in a food that is high in carbs. Well, is it true that foods that are high in carbs have generally high vitamin C content? Well, to see if this is the case, now we're going to go back to our t-apply function, and instead of the max statistic, we're going to use the summary function. We obtain the following two sets of information. The first set corresponds to the foods with low carb content, and the second set of information corresponds to foods with higher carb content than average. Now, the statistical information that the summary function gives us pertains to the vitamin C levels. This means that we have on average 6.36 milligrams of vitamin C in foods with low carb content, and on average 16.31 milligrams of vitamin C in foods with high carb content. So, it does seem like a general trend. Foods with high carb content are on average richer in vitamin C compared to foods with low carb content. Now we reach the end of our first recitation. I hope this was a good exercise to familiarize yourself better with R and learn some fun facts about nutrition. Stay healthy!